Hello everyone. So today I have started with for this time I'll be selecting and going ahead with the LCS. So for LCS we would be doing some 8 questions, and after that we'll switch over to another DP topic, basically DP subtopic, and that would be LIS, or we'll choose that which one we want to go ahead with. But now, for time being, we'll be going ahead with LCS. And as I'd already mentioned that how I would be doing is that first I'll show you how we will be going ahead with recursive solution, and after that we would be going ahead with memoizing the same and then going ahead with the bottom up DP. So this is how we will be doing our first question for the day, and that is the LCS. So this is a base question for a lot of questions, because as we go ahead with this LCS question, then after that only we would be able to do a lot of questions which are related to this. So that's why we need to maintain the consistency and do daily one of the questions regarding LCS, so that we are able to recognize the pattern that this is the LCS question. So let's start with the first LCS question today. So as you can see that I've taken this example ABCDE and ACE. So the basic meaning of LCS is longest common subsequence. So first comes the part that what is subsequence, what is substring, and what is subset, right? So as this question requires subsequence, right? So for that portion, I'll let you know that what a subsequence is. So basically, when two strings and common class are there, and now here comes the part of subsequence. So for subsequence, we need not to be having consecutive elements which are there, but we are required to have all the elements which are present in that particular string, basically the chars which are present in that string. They need not to be consecutive, but they need to be having the same relative positions. Means when we are having this A, B and then C, then what is the subsequence? This ABC is itself, it is not a subsequence because they all are consecutive. But if we have something P here, then A and then B and then C. Basically now ABC from this particular string would be a subsequence. But earlier alone this ABC was not a subsequence, but A and then C, if we take them, then AC was a subsequence. So this is a thing which we are required to take in this particular question, and which we would be doing in this question. So now comes the main part, that how we are required to do this question. So as it mentioned that we are required to find the longest common subsequence. So now you know that what is subsequence, right? So now comes the part, the common. So for the common part, we would be given with the two strings which are there, means this one and this one. Two strings are given, and in that we are required to figure out the subsequence, and on the aspect of being common, we are required to figure out the longest common. So that is the thing which we would be doing in this particular question. So now, before doing this question, let me show you that what are the constraints for this question, as I haven't mentioned constraints here. So here you can see the constraints of this question are till 1000, means minimum 1 would be there and at max 1000 would be there, and it only consists of lowercase English characters only. So that's why we are just required to keep a check for the lower English characters only, and then as the constraints are such a lower, so that's why we can apply DP on this question. So now let me explain you that how we are required to do. So first comes the part about the recursive solution. As earlier only I told that first we are required to check for the recursive solution. So here's the thing. Now whenever we are given with that which one we are required to choose, right? So in choosing and non-choosing, there comes the part of recursive solution, and for that aspect only we will check that how we are required to choose and not to choose. So that's why for this recursive solution, first comes the part that what are the choices which are being there, right? So for the choices, we are having that either we need to take this particular character, or we are not required to take this particular character. So that is either we are required to take it or we need to skip it. That is the thing which we are required to check in this. So this is the first thing which we are required to do in a recursive solution. Now comes the next part, and that part is the base case. That what is the base case of this question? So the base case here would be that we would be see how we are required to check about the base case, or before getting to the base case, we are first required to check for the recursive, means the recurrence relation of this particular recursive solution. So here comes the part that what would be the recurrence relation of this particular question. So the thing is that because we are required to check for the common and non-common, right? So what we would be doing is we will be checking that if this particular both of them are common, right? So in that case, what would be the thing which we would be doing? See, as per the question, we are required to find common, right? So we'll check that as it is common, right? So here we found one character. So that's why we will be adding 1, right? Now comes the part that as we have already chosen, so now we need to move ahead. Means for both of the strings, we will be directly going ahead. Means in this first string also and the second string also. And for the part that when we are required to skip it, right? So there could be a case that by skipping one character from the string 1 or skipping one character from the string 2, we can figure out with the common characters, right? So in that scenario, we will be doing this particular thing. So in that scenario, what we would be doing? Then in that thing we will be doing this. That will either skip first one or we'll skip the second one. So that's why we'll check that whosoever returns the maximum out of both. So that's the thing which we will be doing here. So in this recursive solution, now we are able to figure out that what is the recurrence relation here. Means we are given with 2 strings, and in those 2 strings, if there is common, then we'll skip both of the strings and we'll add 1 that we have already found one of the character. And if we are unable to find characters there, means common character, then we'll either skip from the string 1 or we will skip from the string 2. So that is the thing which we will do, and out of them whatever would be the maximum, we'll keep that in our skip variable, right? Because we are required to figure out the long case, and that's why we are doing maximum out of both of the cases. So that's the thing which we would be doing here. Now comes the part that what would be the base case, because in a recursive relation, when we are going into the depth of a particular recursive tree, then there should be a base condition at which it is required to stop. And as in this particular string, we would be traversing the whole string, right? So there we can give a constraint about the string length, right? And it exactly depends on our recursive relation, that either we are moving ahead, that is moving towards the end of the length, or we are moving backwards towards the zeroth character of the length. Means either we are moving towards the n-1 character or we are moving towards the 0th character. So according to that only, we are required to give our base case. So here we are moving towards the n-1 character, so that's why our base case is that if n equals to the size of the s1 or m equals to the size of the s2, then we will be returning 0. So this is how we would be determining our base case. So in a recursive solution, first we need to check for the choices, then we need to check for the recurrence relation, and after that we are required to check for the base case. So this is the thing which we would be checking in our recursive solution. So for this only, for better explanation, I have already made a particular tree. So how it would be that if we check for S0 and then S2 0, then in both of them we are having A. So both of them are common, right? So then it will go into the depth of that particular by skipping both of them and adding 1 to the same. So now 1 is added to the same, right? then it will check for the first character, because earlier it was 0th character. Now it will be checking for the first character of S1, and then it will be checking for the first character of the S2, and both of them are not same, right? So that's why at that position only, now we are having two cases, that either we need to skip for the string 1's character, or we are required to skip for the string 2's character. So that's why in that context, what we will be doing is, we'll then further move ahead in this particular tree, and then we will be directly checking that whosoever is returning the maximum. So in that scenario only, we'll check that either of them, then we'll first go into the depth of the first condition, when we are checking for the, means basically when we are skipping for the first string's character. So that's why we are checking that CC is there, right? So both of them is a match. Now as both of them is a match, so we'll add 1 and skip both of the characters, means both of the strings, and then again go ahead with the same thing, that either we will skip for the string 1's character, or we'll skip for the string 2's character. And like this only we are moving ahead, and at the end we reach at that case when n equals to size of the first string, right? So that's why it started for backtracking at that position. So this is where our base case comes into picture, and this is the thing which we are required to do, and now our answer would be being calculated after this only, means now it will be returning, and here 1 got returned, and then after that again 1 got returned, and then 2 got returned, because here we encounter with the 1, right? So like this only it will be at the top, but before reaching the top, it will also check that are there any other conditions which are still being left, means this condition which was left, right? So it will check for this one, and when its base case hits, then only it will move towards its parent caller, means a complete recursion with a complete recursive stack. And this is how, means when we reach a base case, then only our stack unwinds, and that's the scenario, means here only whatsoever the things which are there, means all these which are there, then it got unwinding. So this is the thing which we are doing here. Now comes the next part, that now we are having a basic understanding of this recursive solution, right? Now how we are required to code this particular solution. Now that's the thing. So for this particular, I don't remember that I have written here. So the recursive solution for this particular question is this, that here means our function which was given to us was this one. We are given with 2 input strings, and in these 2 input strings we are writing our own recursive solution here. So for that recursive solution we have named it as sub, and here we are passing with the input string, and then the starting point, and then string input string 2, and the starting point for the input string 2. So this is the thing which we are going to pass here. And now comes the part that how we are going to code this question. Now, as I already mentioned, in the recursive solution we work on the choices on recursive recurrence relation and the base case. So here comes the choice part, that either we have to take it or we need to skip it. So that's why we have declared here the variable in take and skip equals to 0, because this is a starting point. Now comes the part of the base case, that if it reaches the end of the string 1 or it reaches the end of the string 2, then we are required to return 0, and that is the thing which we are doing here. Now if s1 of n equals to s2 of m, here n and m are basically the variables which we are required to take for going ahead in our question. So then at that point we will return our particular function itself with passing the parameters n plus 1 and m plus 1, but adding 1 to it, the thing which we were doing in our that recurrence relation. And here then at the end we'll return skip equals to maximum of sub of, either we'll skip the first or we'll skip the second. So this is the thing which we would be doing. So here's how we would be coding this particular recursive solution. So this is how we can go ahead in the interview time, and this is how we can first explain this particular point, and then we can do memoization of the same. So yeah, and if we do all this in the interviews, then that will surely make possible for you that you know the basic understanding of this question. So it would be pretty much good. So yeah, so for interview perspective, this all is there, and now I'll show you about the memoization and bottom up DP. Now comes the part that how we are about to do the memoization about this particular question, right? So here's the recursive solution, and now comes the part about the memoization. So for memoization purpose, we all know that for why we do memoization. It's all for the case that in the recursive solution there are a lot of cases where we are required to means there are a lot of sub cases which are there with repeat itself, right? So that's why in the memoization what we do, we simply take a vector of vector int, right? Or we can take a vector of int, or we can take any array, or we can take any unordered map. And how we are required to take these things means choosing a 1D or 2D, means how we are required to memoize a particular solution, means a recursive solution, right? Because here also we have taken this vector of vector int, right? Now this part comes to our mind, means how we are taking this 2D or 1D. So here you can see about the choices. So what choices we made? We made that either we need to take it and need to skip it, right? But the thing is here we are not going ahead, means for the fact of that this vector int, basically this 2D and 1D, for that fact we are not going ahead with choices, but we are going ahead with the dimensions which we are taking here according to the input string which is there. Means see, how we are making here choices is that either we are taking this particular string, or we are taking that particular string, or we are taking both of them together. So here the variable part is that we are choosing this particular string, or we are not choosing this particular string. We are choosing this particular string, or we are not choosing this particular string. So here there are two strings, right? So because of these two strings only, we are going ahead with this two-dimensional vector. In C++ we can go ahead with vector, in Java with the array list which is there. So according to language that changes, but as I'm coding in C++, so that's why I'm taking this vector of vector in. So how we are memoizing this particular recursive solution? So everything is same. The way means every portion is same. Only portion which is different is this particular, means I have taken a data structure, a new data structure. Then comes the part this, it is already same. Now here comes the part. But means before going ahead with the same, okay, I guess it will become much small. So before going ahead, in the main portion of this question only, I have first, means earlier I have defined that vector int as publicly, but I could also define it as private variable also. But in time being I have defined publicly, but prefer to define it as private variable. So here, now what I'm taking is, doing is I'm directly resizing this particular DP. So here I am resizing it with the first string size and the second string size +1. The +1 is simply for the base case that we are passing, and this -1 means that this would be acting as the what we can say as an indicator that yeah, if it is -1 means it don't have any value earlier, so we won't be getting any particular answer from our DP. If it is not -1, then a sub case is already stored at that particular position, and then we will get our answer from there. So that's why we are getting -1 here. Now comes the next part, that is if DP of n m not equals to -1, the thing which I was saying earlier. If that is not the case, then we are required to return dp of nm, right? This is the thing. This is the only change which we are doing here, and next one more change is there. So this was already the same, the base case which was there, but here rather than returning 0 directly, here we will assign that 0 to our vector of vector int, and then we will return that particular point. And then comes the part about this particular, that if both of them are equal, then what we'll do means, earlier we were directly returning this case, right? Now we will first assign it to our dp, and then only we will return. And for the next case where we were having that skip portion, right? So for there, first we will assign it to our dp, doing the same thing, and then only we will return. So this is the thing which we will be being transformed from a simple recursive solution to a dp solution. So this was all which we are required to do for memoization part. Now comes the part about the bottom up dp. I hope now it is much clear from recursive to memoize. Now comes the part for the bottom. So about the bottom up, see, the thing is, as the name suggests, it is bottom to up, right? Earlier it was top to bottom, means we were going ahead in that manner that whatsoever was stored previously, we were at the top and we were just making our getting our sub cases and then getting the answer from that. But here the thing is somehow different, so that's what we are required to go ahead with. So now, for doing this particular, again, as it is recursive only, right? Recursive changed to dp, that was that memoize part. But now comes the part that somehow it is also derived from recursive solution only. Only thing is, some of the methods are being transformed, like the base case would be transformed into a tabular portion. And that tabular portion, we need to keep in mind that how that particular base case is required to be, to be taken into consideration. So for that part only, we make our row 0, column 0 at the first position. These are acting as our base case. Earlier what we had done was, we have taken a vector of vector int with the size just +1. That +1 was acting as our base case, means that particular position, that extra space. And now here also this extra space is acting as our base case. Now how it is being modified as base case, now you'll get to know. So now comes the part in tem and in tem. Means now we are taking the first string size and the second string size. Now we are defining a 2D array where the size is m plus n, m plus 1 and n plus 1, right? And y plus 1 is there for that base case. And now first we are making all the rows at the first, means basically all the columns at the first row, we are making them as 0. Then all the rows at the first column, we are making that as 0. And that is the thing which we are doing here. So this all is acting as our base case for this particular question, for moving ahead with our bottom up DP and making that tabular way of doing this question successful. So now for int I equals 1, because we have already put that I equals to 0 as 0, now we can access that also. So now we are starting from I equals to 1 and j equals to 1. Now in our inner loop, what we are doing is, we are checking that is our previous. Now here comes the part why we have put our all first row and all first column as 0, because of this thing only. When we are starting from I equals to 1 and j equals to 1, now when we compare that our I minus 1 and j minus 1, if both of them are equal, yes, both of them are equal. And one more thing for putting them as 0 is, see, in means when none of them is matching, right? So that is means if we say that only one character is there, right? So if there is also not a match, so in that scenario also, it is also one of the case that means at that point it will return 1. So that's why we are taking this 0, means it should be a match, and then at that point we are getting this 1 and adding this to our previous dp of I minus 1 j minus 1, means basically at the starting point only we are writing this. Else it will directly go to else it will directly skip that I minus 1 or j minus 1 and check that out of them which of the maximum and assign that to dp of I j. And this is the thing which we are doing here. You can pretty much see that in the recursive solution also we were doing plus we were directly skipping both of them, or we were skipping either of them. That was the thing which we were doing in our recursive solution, right? And the same we are doing in our bottom-up solution also. Only thing is that now we are doing it all in a tabular form, so that's why we are filling a table and then extracting a value. That is the thing which we are doing here. And when it was recursive solution, it was simply that we need to keep in mind about the recursive stack, how it is unwinding, and all such things we were required to do there. And now at the end, what we would be returning is dp of m in, because this is that position at which we will be able to find the longest common subsequence. Because what we are doing is we are directly adding 1 at every position when we found that they are common, right? And also we are checking that what was there at the previous position. So that's why what would be the next would be the summation of previous one and the present one. So when this is the scenario, then we get our answer at the end position, that is dp of mn. And that is the case here. We are getting a solution here. So this was all for this question. Now comes the part for the time complexity and the space complexity. So the time complexity will be n into m, and the space complexity is n into m again, because the thing is that we are taking a table, a 2D vector, means table is for the from that 2D vector only. And how the time complexity is n into m? Because of the fact, okay. So why the time complexity is n into m? You can clearly see that there is a loop of m length and then there is a loop of n length, and both of them are nested one, and that's why when we are going ahead with a nested loop, so here the time complexity becomes n into m, and that is the scenario here. So, and space complexity because of this table which we are taking of n into m length. So this was all for this particular question. If you have any doubt, you could comment down, and do like and subscribe to the channel. Thank you.